Okay, today we are going to look at the polar coordinate using double integral. Move to my notes directly in the Microsoft Word. So the polar coordinate is actually solve it when the area of the region R is in either is circular area or is bounded by the polar graph. For example, these two, this region R, the blue color is actually bounded by two polar graph. Let's say the bottom curve here is R equal to G1 theta. Okay, the top curve is R equal to G2 theta. And then we have the red color. This is actually this region R is bounded by the theta equal to alpha and theta equal to beta. In this case, we'll solve it using polar coordinate because it's normally we use polar coordinate. First, we see the area is bounded by circular region. Circular region like circle, or semicircle, quadrant of circle, or you have a two polar graph. In this case, R equal to G1 theta, R equal to G2 theta. Then theta from alpha up to theta equal to beta. Then area that you learned in double integral, A is actually double integral A over region R. Region R in this case is a blue color here. And the region R, now we divide here. Let's say this one is theta equal to alpha, so alpha plus delta theta. This line is alpha plus 2 delta theta, and so on. And then delta R, this curve, this this is delta R, 2 delta R, 3 delta, and so on. So R is actually what's here from the origin up to R in this case is actually the radius of a circle. And in polar coordinate, it's actually we have x squared plus y squared equal to r squared. So it's actually this is a circle which is centered at origin with radius r unit. If you have x squared plus y squared equal to r squared. So this is a r. The r from 0 touch to the radius of the circle. And then for polar coordinate is actually we get the formula. This is a x, this is y, and let's say this is theta. Let's say this is an x unit, and the vertical length is a y unit, r. R is the point, is a magnitude actually. R is if in circle, r is a radius of a circle. It's actually magnitude that touch from the origin up to here. So that's why using Pythagoras theorem, you have x squared plus y squared equal to r squared. And then when you take the cos theta is actually you have over 6, which is y, divided by the hypotenuse, which is r, or y equal to r cos theta. By taking sin theta, so this one is sin. Cos theta is a adjacent length, which is x over r. That's why x is actually equal to r cos theta. Okay, x is r cos theta. Sin theta is actually y over r. Okay, or y is r sin theta. So you have x is r cos theta, y is r sin theta. Okay, and if you take tangent, so your tangent theta is actually y over x. So with this you can find that theta is arctan y over x. Okay, after that, okay, if you want to solve double integral using polar coordinate, x you replace by r cos theta, y by r sin theta. Okay, if you want theta, okay, from here, theta is actually arctan y over x. Okay, y over x, and then okay, the dA, change the dA here. dA is actually a small area. Okay, it's a delta. Okay, for example, you focus on this red color. This is a small area. dA is a one small unit area. For example, this red color area here, delta AK. Because as you know, double integral is actually when you sum up all the AK, delta AK here, okay, and then okay, up to, let's say your K from 1 up to okay, the infinity, okay, here, then will be equal back to the double integral dA over the region R here. Okay, and how to get the formula for dA in polar coordinate? Okay, you know, okay, here, the arc length, this is a delta theta, okay, and this line here, this is delta R here, because R is a red color, a small unit of R is delta R, so delta theta times delta R, okay, and delta R is actually, as you know, we have this arc length, S, we have the R theta here. S is the arc length here. Okay, the arc length is actually equal to R theta. S is R theta. Okay, so that's why this delta theta is actually this one is delta theta here. Okay, here. So because we have the formula dA, okay, when convert to polar coordinate, dA is actually r dr d theta. R dr d theta. Okay, dr is here. Okay, r d theta is look like your arc length. Okay, theta change to d theta, so you r d theta, and then multiply by this dr. It's some sort like this one, this curve. Okay, S here is a r, okay, d theta, r d theta multiply dr. That's why dA is r dr d theta. So this is a conversion scale from Cartesian coordinate to the polar coordinate, where the x you change. Okay, in polar coordinate, okay, we have no longer x, y, we have r and theta, where actually, okay, if we have an x variable, x you change it to r cos theta, y we change to r sin theta, dA become r dr d theta, r dr d theta, where x squared plus y squared equal to r squared. This K formula can be derived using just this like this triangle in the first quadrant. So before I proceed, okay, do you have any question? So this is a double integral in Cartesian coordinate. If the region R is circular region like example 1, we want to find area of a unit circle. So this is circular region. Okay, or we have like this. Then we will use polar coordinate. We use polar coordinate. dA you change to R dr, dA change to R dr d theta. If you have x change to R cos theta. If y change to R sin theta. If you have x squared plus y squared, then change it to R squared. Okay, and then if we integrate respect to R first, so we need to put out the limit for R. Okay, limit for R, if just now the general case, limit for R in here, this one, if for this K region R, okay, the lower limit of R will be G1 theta, up to upper limit will be G2 theta. Okay, and then theta, K is from here, theta is rotate, K from positive x-axis, theta is 0, okay, up to semicircle, theta is pi. If a full circle, theta will up to 2 pi. Okay, and for this region R, theta is actually from alpha, okay, here alpha, it rotate up to theta equal to beta. So mean, okay, for this case, it's actually theta is from alpha up to beta, R is from G1 theta up to G2 theta. So again, you can see, okay, for double integral, the outer integral must be constant value. The inner can be constant, or can if you integrate respect to R, or it can be function of theta. And then we look at example 1. Find the area of a unit circle x squared plus y squared equal to 1. Okay, using dy dx, dx dy, okay, these two same look like changing variable. Okay, and the new thing is this one, polar coordinates. So I'm going to copy this one to a new document. It is using the polar coordinate. So the solution, okay, we have your circle, negative 1, 1, this is 1, negative 1, okay, freehand, so look like not symmetric. Okay, so if you want to solve using dy dx, we okay, copy using, look like we sums the area of the circle using vertical bar. So from x squared plus y squared equal to 1, if you want to use dy dx, then from the circle equation, you have to make y as a title. Okay, and if you cut it, if you make y as a title, then y, you have positive, negative, square root 1 minus x squared. 1 minus, this is x squared. So, okay, so this one, for positive y will be your upper semicircle, upper semicircular curve, which is given by y equal to positive square root 1 minus x squared. Okay, the bottom, the black color will be y equal negative square root 1 minus x squared. So if we use dy dx, okay, as we learned last week, mean that you look, the region R is bounded by top curve, which is y equal to square root 1 minus x squared, bottom curve, which is y equal to negative square root 1 minus x squared. And you sum the your vertical bar from left, which is x negative 1 up to x positive 1. Okay, that's why your area, you will use x from negative 1 up to positive 1, and then y from negative, lower limit put out from lower curve up to upper curve, negative 1 minus x squared up to positive 1 minus x squared. So area is actually A is double integral dA over region R. So the integrand is 1. Okay, or just put up dy dx. Okay, this is using dy dx technique. Okay, and then you just integrate as usual. Integrate 1 respect to y, you have y. You have y. You have y here. So put up the limit is from negative 1 minus x squared up to positive 1 minus x squared dx. So put the upper limit, deduct lower limit, so 1 minus x squared minus negative square root 1 minus x squared dx. So you will get 2 times integral, negative 1 to 1, negative, negative, positive, 2 times 1 minus x squared dx. Okay, if you don't forget how to integrate this one, you may just use your scientific calculator to integrate it. So just integrate square root 1 minus x squared from negative 1 up to positive 1. It's simple. Okay, you get and then this answer you times 2. 2.1415, this is to get the answer. Okay, this is actually the pi. You check it, this value is pi value. Okay, but if you want to get the pi, you have to integrate manually. So how do you integrate manually? Then you need, this is trigonometric substitution. To integrate manually, the answer here, if you use scientific calculator, in this case you won't get the pi exactly. If you want the pi, you have to integrate manually. To integrate manually, you have to do trigonometric substitution. You let x equal to sin theta, so dx will be cos theta d theta. So integral square root 1 minus x squared dx will become integrate. X is sin theta, so x squared will be sin squared theta. This is dx. This one is dx. So dx is cos theta d theta. So 1 minus sin squared is cos squared. Taking square root, you have a cos theta. Okay, multiply your cos theta d theta. So you have integrate cos squared theta d theta. Okay, and then you have to change the cos squared theta d theta to the formula. Change the cos squared theta. What is the formula to change the cos squared theta? Okay, cos squared theta, okay, you have the formula is actually half of 1 plus cos 2 theta, theta. So, okay, so now you can integrate 1 respect to theta with theta. Okay, integrate cos 2 theta is sin 2 theta divided by 2. Okay, so you this one theta, you have to put out the limit. Okay, otherwise you have to put back theta is an arc sin. Okay, you have here theta. Okay, theta is actually from theta here. Theta is arc sin x, and then sin 2 theta. Okay, or you want this? Okay, you just put out the limit. You have x is actually sin theta. So when x is negative 1, x is negative 1, so negative 1 equal to sin theta. Okay, so what is the theta value? Negative pi over 2. Then you add sin negative 1. This is a sin. Sorry, we want add sin. Add sin negative 1. Okay, provided. Okay, if you want to get change it to radian. So you have negative pi over 2. So when the x is positive 1, 1 equal to sin theta, implied theta is positive pi over 2. Okay, so now here, integrate 1, okay, from negative 1 to positive 1. Okay, when you change to theta, the limit is from negative pi over 2 to positive pi over 2. So here, this is from negative pi over 2 to positive pi over 2. That's why the integral you get negative pi over 2 plus 2 times pi over 2 will become sin pi divided by 2. So minus, okay, substitution of negative, the lower limit, which is negative pi over 2, okay, plus sin 2 times negative pi over 2 becomes sin negative pi divided by 2. So this one you get pi over 2, negative pi over 2 will be pi. This one will be pi. Sin pi over 2, sin pi is 0. Sin negative pi, this one becomes negative sin pi, okay, and sin pi is 0, so this one also 0. So that's why pi over 2 minus negative pi over 2 you get, okay, half pi over 2. Okay, pi over 2 is actually, just now we evaluate this one, 2 times pi over 2. That's why the answer is pi. Okay, this is manually. And it just now, this is, okay, using scientific calculator straight away here. You get this is 1.5707. This is actually pi over 2. Okay, this integral you get pi over 2. So you got 2 times, and so you get the answer is pi. So you notice, okay, if circular region, if you use, okay, Cartesian coordinate, okay, or dy dx or dx dy, you have a longer, okay, step to do, and it's more tedious. You need with the, okay, trigonometric substitution. Okay, this is using dy dx. Okay, if you want dx dy, then the circle is actually, you have to cut it vertically. So you have the left, okay, from x squared plus y squared equal to 1. Okay, if you want dx dy, you have to make x as a title. So x, you have positive negative square root 1 minus y squared. So the left, okay, left curve is actually negative, x negative. So left curve is x equal negative square root 1 minus y squared. Okay, the right curve, which is x equal positive square root 1 minus y squared. And then, okay, if you use dy dx, it's actually you sum the region, you sum your region using horizontal bar. You sum this region using horizontal bar. That's why your A is actually dx dy. So x from the left curve, which is x equal negative. X is negative 1 minus y squared. Left curve, the red color. Right curve, which is the blue color, which is positive 1 minus y squared. So we integrate respect to x from the left curve, which is x equal negative square root 1 minus y squared, up to the positive square root 1 minus y squared. And then dy is actually, when you do the inner dx, is actually you find one horizontal bar, the area of one horizontal bar. Later on, you sum it from, okay, this is negative 1 up to positive 1. So this is a unit circle centered at origin. Okay. Then you sum the horizontal bar from bottom up to top, which is y from negative 1 up to positive 1. Okay, if you check with your dy dx, okay, for circle, if you use dx dy or dy dx, seem like just change variable. Just now this is dy dx, then here this is x, this is x, this is x. That's why if you solve it again, it's only changing variable. Also look here. Dx dy, this one become x, become y, x become y. To solve it, you still get the same answer, which is pi. So for dx dy, you will get the same answer also, pi. And then now we are going to solve it using polar coordinate. Okay, see the polar coordinate. Okay, if polar coordinate is actually, we'll sum the area using, some sort like here. So the small region is here. And then we'll sum it from here. This is theta 0. Full cycle also, we rotate it. So up to theta equal to 2 pi. Okay, your r is actually, you have x squared plus y squared equal to 1. So r squared equal to 1, r will be 1. Okay, for r is actually magnitude, that's why minimum is 0, maximum up to the radius of the circle. That's why a, in this case, dA is r, dr, d theta, where r from 0 up to 1. Okay, even though you solve here, don't give me r from negative 1 up to 1. R is magnitude. So minimum is 0, maximum in this case is up to the radius of the unit circle, which is 1. Okay, and we have the full circle, that's why theta, okay, theta from 0 up to 2 pi. Okay, if you just find the area in the first quadrant only, so your theta 0 up to pi over 2. If for semicircle, okay, up to pi. Full circle up to 2 pi. Okay, now, so now in polar coordinate, the same thing, you integrate respect to r first, where theta is constant. So integrate r dr, you have r squared divided by 2, so I factor out as a half outside the outer integral. So r from 0 to 1, so maintain your d theta outside. Then you put in the limit we have 1. So lastly become integral 0 to 2 pi d theta. Integrate 1 respect to theta, you have theta. Theta from 0 to 2 pi. That's why answer is pi. So when you compare with Cartesian coordinate where you use dy dx or dx dy, for circular region, you use polar coordinate will be easier and faster. Few steps only and the integral is easy. Compared to just now, you need the, this is using trigonometric substitution. So this one just simple integration only. So this one I use one unit circle. You know the area is actually, area of the circle is pi r squared. So r in this case is 1, that's why answer is pi. So before I proceed, any question or not?
No.
No. You ignore?
No.
No. Okay. Okay, the next class I think I will show the limit only. The rest I think you can integrate. Okay, example 2, find the area of region R. The region R here is a blue color. Okay, bounded by the curve x squared plus y squared equal to 4. Okay, this is also circle centered at origin with radius equal to 2. Because we have r squared equal 4. So r will be equal to 2. Okay, but this one, top curve is r equal to 2. Bottom is y equal sec 2. And you know y is actually r sin theta. So that's why r is sec 2 divide sin theta, or sec 2 1 over sin is cosec CSC. So in this case, okay, how you determine the r actually? Here, you draw a slanting arrow. So touch here, this curve is actually r equal to sec 2 cosec theta up to r equal to 2. So okay, for here, this one, so r is sec 2 cosec theta up to r equal to 2. So dA is r dr d theta. Okay, theta is from, so to get theta, we make this one, this angle. Okay, this point, x is sec 2, y is sec 2. Y equal to x. So means, the angle is actually pi over 4. Awesome. Y if x is sec 2 unit, y is sec 2 unit. So provided the angle is 45 degree or pi over 4. Okay, so this is theta is pi over 4. Okay, up to the y-axis, positive y-axis theta is pi over 2. And up to when you touch positive y-axis, theta is pi over 2. From here, this is theta equal to 0, but your region R not touch theta equal to 0. It touch here, y equal to x is theta equal to pi over 4. Theta equal to pi over 4. So up to theta equal to, so this is pi over 4 up to pi over 2. Then you just integrate this one. Integrate r dr, again r squared. I normally factor out half outside. So you have sec 2 cosec theta up to 2. Then this is a d theta. So plug in upper limit 2 squared, you have 4, and then minus, okay, you have sec 2 cosec theta squared it, so d theta. Okay, so sec 2 squared, you have 2 cosec squared theta, d theta. Integrate pi over 4 to pi over 2. This is at the bottom here. So integrate 4, you will have 4 theta. Integrate cosec. Okay, what do you get? Integrate cosec. The integration is actually the anti-differentiation. Means that we differentiate the cotangent theta. We have what? Negative cosec squared theta. So that's why you integrate negative cosec squared, you get back positive. Integration is actually anti-differentiation. That's why you integrate negative cosec squared, you get cotangent theta. That's why this is plus 2 cotangent theta from pi over 4 up to pi over 2. Simplify, so we get actually is 2 theta plus cotangent theta from pi over 2 up to pi over 4. So plug in upper limit, so you have 2 times pi over 2 plus cotangent pi over 2, okay, minus 2 times pi over 4, we get pi, okay, over 2, so plus cotangent pi over 4. So this one you get pi. Okay, cotangent is actually 1 over tangent. The cotangent theta is actually 1 over tangent theta. So you have 1 over tangent pi over 2. Okay, tangent pi over 2 is actually, when you have tangent pi over 2 is infinity. So 1 divide infinity, this is 0. So minus pi over 2 minus, okay, cotangent is 1 over tangent, so tangent pi over 4. So you get pi. Okay, this one, because okay, this part minus pi over 2. Tangent pi over 4 is actually 1. That's what just now we said. If we have here pi over 4, okay, these two must be same. The length must be same. That's why tangent pi over 4, the answer is 1. So minus 1. So pi minus pi over 2, so you got pi over 2 minus 1. The area is pi over 2 minus 1 using polar coordinate. And when you check using geometric, it is actually correct. Huh? Using double integral, you get the answer is pi over 2 minus 1. Okay, because if you put out here, this area, okay, is actually 1 over 4, because it's quadrant of your, okay, circle. Pi, radius is, okay, 2, so 2 squared. So we have, okay, this area is pi, okay, minus the square. The square, okay, answer is 1. Okay, 1. This is equals to minus 1. Okay, you see this one. I cannot use this one. This area deduct here. Sorry, I couldn't use that way because the whole thing deduct here, I still got this part. So it's troublesome. Okay, at first I thought is using the quadrant of circle deduct here, so I get this one and this one. So it's troublesome. You have to find the area here. So that's why if you're using the polar coordinate, this one, the R for this case is here. Lower limit is R equal to sec2 cosec theta up to the upper limit, which is R equal to 2, and the theta is from pi over 4 up to pi over 2. Okay, this one just forget it, because still need one more step. If you want to use quadrant of circle, deduct this area, okay, deduct this area, and then have to deduct this one. So okay, the second example, okay, is it okay? Especially for the limit and the limit of R and limit of the theta.
I don't get it. The limit of R.
Because the R here, the touch this one up to here. You see the red color arrow.
Okay, okay.
For polar coordinate, you draw the slanting arrow. Okay, this slanting arrow as the text here enters at. Okay, this one, this is cause this point is x sec 2, y sec 2, y equal to sec 2, y is r sin theta. That's what I said just now. Y equal sec 2, y is r sin theta equal to sec 2. That's why you r. Okay, y equal to sec 2 in polar coordinate is actually r equal to 2 divide sin theta. 1 over sin theta is cosec theta. So the r, okay, in this case, okay, because your region is here, enter at this y equal to sec 2 in polar coordinate is actually r equal to sec 2 cosec theta up to r equal to 2. If the normal circle only like this now, just now, okay, this one, the first example, the unit circle, okay, you have only unit circle in here, this one. This example, this is 1, negative 1, negative 1, 1. Okay. R 0 up to here, R equal 1. How do you get R equal 1? X squared plus Y squared equal 1. R is 1. R is positive. R is magnitude. So R from here up to here, and the R you rotate. So this case, theta, okay, from 0 up to 2 pi. Okay, R is actually 0 up to 1. Okay, this one is full circle. You may have the region of like donut region. Let's say this one is R2. This is R1. So you want area of this donut region. Then, in this case, you draw the slanting arrow. So, R touch R equal to 1 up to R equal to 2. That's why the R is from 1 up to 2. So, R d theta. Okay, if let's say you just want the donut in the first quadrant only, like just now. So theta 0 up to theta equal to pi over 2. Cos theta, you rotate it. This is theta 0 up to positive y-axis theta equal to pi over 2. If you want some, okay, up to semicircular, if you want up to here, then theta up to pi. Okay, if you want all fourth quadrant, then theta up to 2 pi. Okay, this one is the area bounded by two with r equal to 1 up to r equal to 2. But here, how to get from y equal to sec2, when you convert to polar coordinate, you get r is sec2 divide sin theta or sec2 cosec theta. That's why the r lower limit is actually r equal to sec2 cosec theta up to the upper limit, which is r equal to 2. Compare this one, r1 up to r2. But the normal circle, because you have only one square here, from the origin r0 up to r equal to 1. Is it clearer compared to just now when you look at the donut area?
Yes, doctor.
So the third one, find the volume of the surface which is bounded above by z equal to y, below by a region x squared plus y squared less than or equal to 1 in the first quadrant by using polar coordinate. Okay, recall back the volume. Okay. Volume using double integral. Basically, double integral f x y dA over region R. And fxy is actually equal to z. So in this case, you plug in it's z. Z is what? Z is y. So y dA here. Fxy is actually equal to z and z equal to y. So your volume is given by double integral y dA over region R. Okay, the region R is actually quadrant of unit circle, okay, which is centered at origin. Okay. Your region R is actually like here. Okay. This is x squared plus y squared equal to 1. So R will be 1. In the first quadrant, so theta here, theta is 0 up to here, theta equal to pi over 2. Because we want to see the R, okay, not here. So this is R0 up to here, which is R1. Since the region R is circular, we use polar coordinate. So y is r sin theta. dA is r dr d theta. Okay, and then r in this case from 0 up to 1, theta from 0 up to pi over 2. So when you integrate respect to r, theta is constant. So here we have r squared. So integrate r squared, 0 to pi over 2. Integrate r squared, you have r cubed divide 3. So I bring out become 1/3. 0 to 1. So we factor out sin theta near to d theta. R times r squared. So integrate r squared, r cubed divided by 3. So I bring out 1/3 outside of the integral symbol. Then you plug in the upper limit, which is 1 minus 0, so you get 0 to pi over 2. This is sin theta d theta. So integrate sin is negative cos. Write out negative. Integrate sin is negative cos theta. So from 0 up to pi over 2. Limit from 0 to pi over 2. So you put out, so cos pi over 2 minus cos 0. The cos term. This is 2 pi. Here is pi 0, pi over 2 here. This point is pi over 2. This is a y equal to cos x. This point is 3 pi over 2. Cos 0 is positive 1. Cos pi is negative 1. Cos 2 pi is positive 1. Cos pi over 2 is 0. Cos 3 pi over 2 is 0. This is from one cycle of the graph of y equal to cos x. Or you can press your calculator. So cos pi over 2 0. Cos 0 is 1. So that's why you get a negative times negative. So the answer is 1/3. So the volume that we obtain in this case is 1/3. So this is incorporates volume as a double integral, and we solve the volume because the region R is circular. We solve it using polar coordinate. So dA is R dr d theta, y is R sin theta. How you get y? Because volume is double integral fxy dA. Fxy is equal to z, and z in this case is given by y. Do you have any question here for example 3?
No, doctor.
No, I think you can get from authors a lot of example, but due to the time constraint, I will stop at the example 3 and move to another topic, which is a surface area.